Okay, so hello everyone, and uh, welcome once again to my tutorials for the marking. Okay, so if you hear any noises, because I have messages coming from the students. Anyway, so what we're going to do in the marking once again, that every one of us is going to mark his own tutorial sessions, and to get that, actually you can apply the filters, and from the filters go to the sections, and then you can select the session that you are working on. For example, for me, I do the Wednesday 9 a.m. and Wednesday 11 a.m. and yeah, I think that's what I'm doing. I'm doing the Thursday 9 and Thursday 1 o'clock. So by clicking that, those are my students. You can see that most of them actually has been applied for the extension. Well, when Taj actually doesn't have an extension, doesn't have a submission so far, that's mean maybe he's not going to do the project. You need to expect that some of the students try to escape the project because they think that they don't want to do it. That's one thing. The other thing is that maybe you will find some of the students who are supposed to be in my session, they coming to your session because they're partner is with your class, or the other way around. So what I'm going to do right now is just to mark one or two examples. And you remember that we do have a marking criteria, but anyways, we're going to have a look here. For this submission, you can see that the YouTube video has been added to here. But anyway, I will go to this SPD Creator, and we're going to have a look at the report. The first thing we're going to do is that Salam, his other student is Matthias. So it's going to be nice to go to Matthias directly here. Paste. So Matthias is here. Okay, it seems that Matthias is not in my group, so it doesn't show up here. So what I'm going to do in this side, I'm going to remove all the filters so I can see his name. So that's one of the scenario. That's why we have one student is in my group, the other student is in your groups. So once again, I will go to the project, and where's the project? I'm going to open that. I'm going to give him the mark based on the work that he's done. So just let me check with the mini project. Okay. So what we just remember that we have one submission per group. So anyway, I will put this one here. Well, I mean, let me check if we are going to have the rubric is going to show up. View the rubric. Just remember that we're not going to use the rubric. What I'm going to look at, and then I'm going to put the points for each student individually, is the amount and the quality of the work done by each student. For example, Salam did the problem one and virtual lab one. So again, to have a look on that, and I will give him the mark accordingly. I can once again use the rubric to give him the grades. So instead of clicking on here, and this make it actually quite confusing, I either get to put the points here, or I can simply guess how much he worth uh, in his work, not him, of course, his work is worth in terms out of 40 from the YouTube and um, from the report. So just have a look here. Done for the reflection. The YouTube video is here, and I can simply open that, and we can have a look on it as soon as we can. Okay, and once again, we go back to here. I'm going to take a look to the Salem parts, which is 1 and 2. So take a look to Salem work. The figure diagrams are there. He gave a description for the work, good introduction. Once again, you can tick that, but I don't want to do it. I'm going to do it on the paper, and then I'm going to add the marks and put the outcome directly, or I can type it here. So once again, let's go up here. I don't want to use the calculator now. So analysis and diagram for the first one, yeah, he got the diagrams. from the Newton law, transition directions. He put the equations. That's okay. The two cases of no slipping and slipping. That's what happened in the first one, which is the slipping, no slipping case. He actually got most of the stuff from the code. We use these parameters. That's okay. The following principles, assumptions are being applied. Once again, he got all that from the MATLAB. Okay, same thing for the angular acceleration, which is the alpha, the acceleration, the friction force to be generated. The results actually coming from the MATLAB are here. The diagram from MATLAB, that's okay. So he's actually doing the parts of, well, we can see that this one is for the final problem he done. For this one is all necessary diagrams has been applied, free by diagram, kinetic diagrams, and kinetic diagrams all being done. For this one is list and the expression of the parameters to define the boundary condition all done. The analysis and the diagrams all done. But I'm not going to do it as I told you, as sticking here. We tried to give no full mark because there's no perfect work. We try to avoid giving a very high marks because everybody may end up with getting the A. I know that, oh, I say well, it's the HD because I know that we would like to give them very high mark, but it makes no sense actually to get a very high mark because we know how they done the work. So we try to be a little bit strict with them. So he got the outputs all good using the MATLAB. That's the MATLAB output. He identified the points where he done the calculation with. Okay, the unknown slipping case, he should show us the diagram where the Simulink and show us that the slipping happened or didn't happen. Okay, so if he didn't use this one, that's he missed something from that. So from this one, I can give him something like a 75%. Now, if you remember that in the Simulink expression, we have an indicator um, for the slipping or no slipping. There's a bottom that will be green if the slipping happened, red if no slipping. He didn't show up that here. Actually, I explained that to them multiple times. I posted a video for that. Same thing done by Bradley earlier. So if they didn't done it, that means they just try to take a shortcut. We shouldn't accept the shortcuts. 75% for this one. Okay, that's out of the 30. So 75 out of the first 15. That's what I mean with the 70%. Now that's done by the other guy. I'm going to come to this one soon. We go to the virtual lab number 1. Virtual lab number 1. Well, actually, this work is very good because you can see that this guy had done too much work. And actually, this scenario compared to task number 1 is unfair because it's too extensive. He done very good job. I can give him something like 85% out of the 15 mark that he's supposed to work on. He put all the results. He made all the analysis. Everything has been described. Comparison of the results. That's very nice. Okay. Uh, he put a discussion on that. So for that, task number 3, sliding for the pipe pendulum. So yeah, this guy did a perfect work. That's actually what we need them to show. So this can be a good example for a good work. Task number 4. Okay, so he done everything. So for the first person, for the first part, he got 75%. For this one, I can give him 85%. Actually, the first one, I can even give him 70%. So let's go back and see the virtual lab number 1. Once again, he done the free body diagrams by hand, which is good. Okay, explain the scenario. I would like to see if he done the last part. The parameters has been explained. The definition of the model parameters, the pendulum properties, the block properties, the fraction coefficient, the initial conditions, the results with the MATLAB, defining the model parameters. Just want to check something. Now, for the equation for this one, I cannot see actually an equation. Here, they may argue that there is no equation, but they supposed to search for the equations. And I sent them actually an example, a video example on how to do the analysis for this scenario. If they hadn't done it, it's the mistake. Okay, so once again, he put the parameters, he did the calculation, he's doing well. Okay, and the data analysis has been shown. Of course, we cannot check all the answers, but actually that's what I saw earlier in the course. Oh, no, wait a second. He got the equations here. So that's for the mu, that's for the v. Okay, and yeah, well, actually, he done the hand calculation, which is quite correct. So I should give him a good mark. Now, yeah, that's the first, the very important part, which is can we make the block tip over? And this is the four tasks we have in this virtual lab. I didn't explain to them in my video, but I did explain to them in the class. And I highlighted that in one of the video. So once again, yeah, he did that, and he should have some equation to be done, and that's something similar to the tutorial we got in the week number 10 on 11. Well, that's it. Yeah. So for this part, I can give him 85%. Okay, 85 and 17%. So if I get to do a calculations. Okay, so where's my calculator? So we are going to have zero point 0.7 times 15 for the first part, plus 0.85 times 15, close the bracket. So now he's standing at 23.25 out of 30. Okay, and now we're going to take a look to the video and see how did he actually work, and see how much we are going to give him out of the 10.
Hello,
Okay.
I am Salim, and the problem we are analyzing is a system where a pipe is attached to a pivot, swinging like a pendulum. We are analyzing the motion by tracking the angle theta t and calculating the forces that and torques that acting on the center of mass. In this presentation, I'll explain how we derive the pipe's motion equations. We are using Newton's second law, assuming a thin-walled pipe, no air resistant, and no strap slipping. By applying Newton's second law vertically, we considered both tangential and centripetal components of the pipe's motion. Then we divided the reaction force Ry by 2 to account for each time on the forklift, giving the final equation Fn. For rotation, we use the parallel axis theorem to get the moment of inertia about the pivot point. This led to the angular acceleration formula in terms of gravity and geometry. And then to find the angular velocity, we use the conservation of energy, the potential energy difference from angle theta 0 to theta becomes rotational kinetic energy, giving us the expression here on this slide. And at the lowest point in the swing, the strap supports both the weight of the pipe and the centripetal force from its angular velocity. That's why the maximum tension is the sum of mg and mw squared O. And here in this slide you can see the final equations we derived. Each comes from applying Newton's law and in different directions, or from energy conservation. We use these to calculate the pipe motion and the strap forces under any given angle.
Hey, I'm Matt. So our goal is to verify these calculations we derived by obtaining values from the MATLAB model and comparing these values to our hand calculation. So the first step is to run the task2 script file, which will run the script and open up the Simulink file. We will be using the Brain-Newton model to obtain our values. So if you head over to that tab and then double click on the pink box called Scope Newton, that will open a series of graph plots that show the values of the different variables we need with respect to time. Since the equations we derived are in terms of theta, not time, we need to use the cursor measurements tool and set the trace selection to theta degrees. This gives us a value for theta for a corresponding time using these two draggable cursor lines for different points of interest. Once we have the value for theta that we want, we can change the trace selection to a different variable we want to obtain values for, which will show up here. Finally,
well, I can tell that I can give them 80% for this presentation. This look good, clear, the images are clear, selected the good parameters for the work. Okay, so now looking for Salim, he's standing at the 23.25 plus 8, so he will get 31.25. Okay, so I'll write down that his grade is just cancel that. I'm going to write down here 31.5. That's his grade. Okay, so just enter and done. Now I'm going to do the work for the other guy. So again, we don't have to give them 38. There's no perfect report. I'm going to do the same thing for the other guy. I didn't have a look yet, but obviously he's going to be standing at the same position. Remember that I say that his work for the first part was 85%, so maybe he will get 85% also for the second part, and this will put him at a higher grade a little bit, but nobody will get a full mark. Nobody got 38 or 37, because this will make it illogical to get these values. Okay, so once again, I'm going to make another video and share